Hello, I'm presenting Lab 3 of Physics 2. Intro. The purpose of this lab is to collect data on RC circuits. The physics principles used are Kirchhoff's node and loop rules, Ohm's law, capacitor rules, and then a brief preview. After a long time, the current in the circuit will be zero when a capacitor is in series and it's charging. The main physics principles. So in Kirchhoff's loop rule, the sum of the voltage, of the change in voltage will be zero. So the EMF is like the battery, and it causes like a 3 volt positive 3 volt difference. And then as we pass through resistors, there's going to be a voltage drop, and it should equal zero. Ohm's law is current equals the voltage over the resistance equivalent. And then the capacitor rules, so voltage equals charge over like the capacitance, and then current versus time is given by this equation. So when the capacitor is charging, the current is going to decrease and it's going to go to zero. Reasoning and assumptions. To get the expected values of the current and voltage drops, we must use the loop rule and Ohm's law. Assumptions for initial conditions. Assume that there's no resistance in the wire, and assume all batteries are ideal and there is no internal resistance to get like the expected values. The system is just the circuit. The surrounding is everything that's not the circuit. Initial conditions. So we measured the 47 ohm resistor to be 46 ohms of resistance, and then the 100 ohm resistor was measured to be 96 ohms. With both resistors in series and connected to the battery, the initial the current is just 19.3 milliohms or milliamps. Sorry. The voltage drop across the 46 ohm was 0.98 volts, and the voltage drop across the 96 ohm resistor was 1.8. Ammeters have zero resistance, and voltmeters have infinite resistance, so they don't affect like the readings of the circuit. All right, main experiment. Okay, so this is with the entire RC circuit with the capacitor, the light bulb, and the battery. So we're gonna make a circuit with the capacitor and one of two different light bulbs. One is measured to be 5 ohms and the other is 1.5 ohms. They're all going to be in series, and then you're going to connect the battery to the light bulb and the capacitor, and measure the time it takes for the bulb to go out, and then discharge the capacitor by making a circuit with just the capacitor and the bulb, and then connect until the bulb dims, and then repeat for the other one. Similarities and differences. So if you notice before, like the voltage drop did not equal 3 volts, it equaled 2.78 volts. So basically the wires have a resistance, and it causes a bit of voltage. So because of the increased resistance as well, the current is also going to decrease. Similarities, the current in the RC circuit went to zero as expected because the capacitor is just going to have infinite resistance towards the end of the timing period. So the bulb dims, and then when the capacitor discharges, the voltage drop goes to zero, or the voltage goes to zero, so there's no current. All right, so if there's no resistor in series with the capacitor, this means that basically the resistance is zero, okay? And then so I equals V over R would equal infinity as R goes to zero. So if the current equals zero, the voltage would fully charge instantly since there's so much charge moving. And this is impossible in real life because there's always going to be some resistance in wires. And also based on the power equation, I equals V, right? This means that there's infinite energy which disobeys the law of conservation of energy. That was my lab. Hope you enjoyed.